Okay, 7.1.4 for 7th grade, titled, How Can I Solve It? It says, basically the gist of this lesson is figuring out easier ways to solve an equation with fractional coefficients. Now, coefficient is a vocab term that means the number attached to a variable. For example, if I have 5x in an equation, this 5 is the coefficient. So this lesson is dealing with, well, what if this 5 is actually 2/5 x equals 3? How could I solve it if I have a fraction coefficient? Because it's much easier when you have a whole number coefficient, right? Okay. So that's the gist of this lesson. Let's do the first problem, 739. Is it 739 or 734? I can't tell. 39. And it says, are we there yet? The Sutton family took a trip to see the mountains in Rocky Mountain National Park. Linda and her brother Lee kept asking, are we there yet? At one point, their mother answered, no, but what I can tell you is that we have driven 100 miles, and we are about 2/5 of the way there. Linda turned to Lee and asked, how long is this trip anyway? They each started thinking about whether they could determine the length of the trip based on the information they were given. So I am going to draw these. Linda's method, here's what Linda said, and she's got her linear model, and it's got a 4 dashes, an X, a 1, and then she's got the little bracket. I can't do it on the bottom, sorry, I'm not artistically inclined. 100 miles and 2/5. And then Lee, her brother, has this going on. He's got a triangle with an X, and then he's got a little triangle with 100, and then he's got an arrow here, and it says times 2/5, and then it's got like a dashed arrow from 100 to X. So it says part A, explain how both of these strategies illustrate their situation. So we've driven 100 miles and we're 2/5 of the way there. So that's their situation. That's what Mom says. So it says explain how each of their work shows that. Well, I'm noticing they're both showing, this one's showing a portion of a whole, and this one is also showing this one's kind of showing like a related triangle side, so that this side would be related to this side. If you multiplied this side by 2/5, you would get 100. So X represents total miles in the trip. And we know that has to be a number bigger than 100, which is why this triangle is smaller than that triangle. So then part B says what equation could represent this situation? And the triangle part kind of gives you a hint. It's saying, well, X times 2/5 will give you 100. So that is what I'm going to write. X times 2/5 equals 100. This is also the same thing as saying 2/5 is, 2/5 of what number is 100? So 2/5 of this number is 100. It's also, you could also say 40%, because 2/5 is also 40%. So you could say 40% of X is 100. So we're kind of going a little backwards on this one. We're not given the total, we're given a portion. Okay, part C says, is the answer going to be more or less than 100 miles? So we can conclude that it has to be more than 100, because if you've gone 100 miles and you're not there yet, then you obviously have to go more than 100 miles to get there. It wouldn't make sense if this was like 50, because then they would have already gotten there. So it has to be more than 100, because 100 is only a portion of the whole trip. And now, that's 739, here's 740, and it's dealing with the same stuff, so I'm thinking about, I'm gonna erase this. Okay, so now we're on 740, and it says part A, or it says Linda remarked to Lee, when I look at my diagram, I see the total distance is 2.5 times the distance we've driven. So think about that. She said the total distance is 2.5 times what they've already traveled. So do we agree, and how can we add labels to her diagram to show this? So I'm looking, okay. So this is what I drew. I'm gonna get rid of this. Actually, I'm gonna get rid of this. So here's what they did. So that's, I figured that as 1 time. That's another 1 time, and that's a half. So it's 2.5 times. The whole thing is 2.5 times what they've gone so far. And I think there was a lot better way that I wrote that down. Yeah, I wrote that down like this. So I put 100 here, and then I put 100 here. Yeah, disregard that. That didn't really make much sense. So there's 100. So this little part, if we have 2/5 and 2/5 and then 1/5, well, break 100 in half and you get 50. So that means that's 2.5 times the 100. Part B says, how long is the trip? Well, 100 plus 100 plus 50 is 250 miles. Yes, sir. And we know because we added 100, 150 with Linda's diagram, her linear model. Okay, let's move on from that one. 741 is having us review a problem that we actually didn't do in another lesson, but I'm going to show you what it's talking about. Okay. So it says review problem 722, which involves similar triangles. How are scale factors related? So I'm going to draw it. It's not going to be very good, but that's okay. Like that. And then it was a little, I didn't draw that one big enough. That's okay. So they're going to be small. This one said 6 feet. This one said 5 feet. And then it had an arrow like this times a number. And then it had an arrow like this times a number. And it wanted to know, what do you multiply 6 by to get 5? And what do you multiply 5 by to get 6? So here's what I wrote. I wrote that these are the scale factors, first of all. Those are the scale factors. So I wrote to get from, oh, this is triangle A, this is triangle B. From A to B, I said, well, you're going to have to figure out 6/1 times something gives us 5. And I put 6/1 because I know it has to be a fraction, because you can't multiply something bigger than 1 to get 5. for this problem. Oh, there's a lizard. So I figured out, well, if I do 6 times 5, 6, I know that this is going to cancel, and that's going to be 5. So this one would be 6 times 5, 6. This one is just going to be flipped from B to A. It's going to be 6/5, because if you take this 5 and times it by 6/5, you get 6. Now I got the 5, 6. It's kind of weird how I got the 5, 6. I noticed, well, I know that they're not evenly going to be, I can't multiply 6 by a whole number and get 5. So I knew it had to be a fraction, and I figured out, well, if I take 6 divided by 5, I'm going to get the unit rate. That's kind of how my brain worked for that one. So keeping this in mind, when we go from a big to small, now I'm going to erase that. It's kind of, it's a weird concept to think about. If I, oh yeah, so from big to small, scale factor is less than 1. Small to big, scale factor, I'm just put SF, is greater than 1. Okay, so that's what we're going to think about as we go through the rest of these problems. So let's look at part B. How can the relationship of the scale factors between similar shapes help Lee? Find the missing scale factor in his diagram. So I'm going to draw his diagram. I'm going to draw it bigger this time. So there's his triangle with the X. There's his little triangle with the 100. And then it goes from X to 100, and we multiply by something. And then it's got the little dotted line, and it says to multiply by something. So I figured out, oh, this was already 2/5, right? If we know that X times 2/5 is 100, we're going to flip it, we're going to reverse it, take the reciprocal, and 100 times, that's a dot for times, 5/2 will give us X. Okay, because that's always going to be the reciprocal. If you're timesing by this fraction here, you're going to times it by the flipped version of it to get to there. Okay, so now we can figure out X. So 100 times 5/2 equals, and that's 500 divided by 2, which gives us 250, which is what we got earlier. Yes, our answer agrees, because it's asking, does your answer agree with what you got in part B of the last problem? Yes, 250. Okay, moving on. I'm going to erase that, blah, 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 blah. 742. 742. As Linda and Lee were talking about the problem from 739, their mother overheard and offered them another strategy. She said, here's how I would start the problem. So she showed them this. 2/5 X equals 100. So then part A, Lee is screaming that he sees a giant 1. So now it's saying, oh, oops, I forgot to put this. So he's like, oh my gosh, I see a giant 1. So it's asking, where is the giant 1? Help him rewrite the left side of the equation. So I'm going to draw a giant 1. I'm going to look at where my giant 1 is. I know 2/5 divided by 2/5 is really 2/5 times, flip it, 5/2, which equals 10/10, which is 1. There's my giant 1. I'm going to try my best here. Ooh, boy. Hey, it wasn't bad. So there's my giant 1. And help rewrite the left side of the equation. So the left side of the equation would just, if this whole thing is 1, then x is just going to be there by, it's like 1x. But you're not going to see anything say 1x. You're just going to see the x, and that means 1x. 1x equals 100 divided by 2/5. So then it says, part B, one way of making sense of 100 divided by 2/5 is as this. That's what that one's asking. And it could be read, how many 2/5 are inside of 100 holes? How many 2/5 can fit inside 100? It's going to be a lot, right? There's going to be a lot of 2/5 that fit inside 100. So it says, with your team, find one way to explain how you could figure out how many 2/5 are in 100. Just figure out 100 divided by 2/5, and you get your 250 like we had earlier. We are speeding along here. 7:43. Says, Lee began to wonder how his diagram could help him solve his mother's problem above. So he showed his work like this. So here's what Lee did. Here's what Mom said. And then here's what Lee did. He did this. I should say 5. So it says, how does Lee's work relate to the similar triangles diagram? What is 5/2 times 2/5 x equal to? So what is he doing here? He's multiplying 2/5 by its reciprocal. Reciprocal means flipped upside down. To get, and what happens if you multiply a fraction by its reciprocal? Well, everything cancels out to become 1, or you get 10/10. 10 divided by 10 is 1. So he multiplied 2/5 by 5/2 to get 1. So that's what this is also a 1. I'm not even going to put a 1 over that. But this whole thing equals 1. Finish his work to solve for x for part B. So his work is going to be x equals 100 times 5/2, which is what we did earlier. 500 divided by 2, 250. So there is another way that we can solve when you have a fraction as your coefficient. Okay, so that's one way, and the previous problem showed another way of how to get rid of the fraction by making it a 1 or a giant 1. Okay, this is the last little problem, and it's part A. If you want to do B and C for more practice, be my guest. Okay, so now we have these new equation solving strategies, and we're going to try out this one. Make sure you try it out before I go over it. So pause right here and try that out to solve for x. So there's a couple different ways you could do it. You could do it like this. You could divide both sides by 9/2, because I want to get x all by itself. So that makes a giant 1. Oh boy. Yep, there's my giant 1. So that pretty much cancels to an x. So don't forget about the other side is 27 divided by 9/2, which is 27 times 2/9. And I got 54/9, which equals 6. So x would be 6. If you want to do it the way we just did in the last problem, you could do it like this. Right, is that what it was? Yeah. You could multiply this by its reciprocal. 9/2 times 2/9. Got to do the same to the other side to keep it balanced. So this all becomes 1. So x is by itself, and then you have 27 times 2/9, which is 54/9, which equals 6. All right, those were some strategies on how to solve equations with fraction coefficients. Hopefully this made sense, and I'll see you in the next one. I think I bumped this. Sorry about that.